Hey guys, my name's Rolf, and what's the Swiss guy gonna demo? He's gonna demo how to build a bank, right? So we partnered for this with Pluto Networks, as well as Infoblox, Nutanix, and for security Zscaler, and I'll give you a little bit of an overview of how this works. So Pluto Networks is a scale-out data center fabric, and so essentially you can consume that in their appliances, where we run as a VNF directly bare metal in what they call the server switch. On the branch side, we use Nutanix, and Nutanix is a hyper-converged everything in one box, and so we run also as VNF in Nutanix. So let me go to the demo itself at this point. So what you see here is you have a green button at the top, which is essentially what I like to call the easy button to go from 0 to too big to fail. And so when I hit this button, any device that's been plugged into the network will automatically show up. So I'm going to prove this node, and you'll see there's about 4 steps which are mostly just accepting defaults that you'll need to go to. And so within about 5 seconds, we'll have this node up and running in your SD-WAN fabric. This is the deployment profile, so we'll just accept the defaults here, and if you have questions about this, please come and visit us. One of the powers of SD-WAN is that you can virtualize the underlay, and so you can have multiple overlays, because obviously a voice application is going to require a very different SLA. So in this case, I'm going to deploy a voice and a backup, a replication overlay on this network. And that's it. So what you'll see within a few seconds is on the topology, you see that this node here has popped up. We'll put it here in Switzerland. And we have the overlay tunnels that are already up and running. So the one other demo that I wanted to show was one of the key ways that SD-WAN is more powerful than trying to micromanage a layer 3 routing protocol to get packets to use active-active multipathing is the ability to measure brownout conditions. What I'm at, this is just the Pluribus node with the instance running. We have the Nutanix node with the instance running here. And then in this screen, we're essentially saying our voice policy is that we want a certain amount of latency, and we want to use multipathing between MPLS and internet. And so, just gonna generate some traffic here. So we'll use a video player to get some traffic going. Alright, so the video player is going. You will see we have traffic multipathing, right? The left screen is MPLS, the right graph is internet. And so what I'm going to do now, we could do a failover, but the much more interesting case is, let's say that your multipathing was 2 internet ISPs. And so generally what you'll see is at congested times, maybe your service will not fully fail, but maybe your loss will go to 10%. And so what I'm essentially doing here with this bad links command is I'm applying a 10% loss. And so if you go back to the video, what you'll notice is as soon as I go outside of the buffered zone, the video is going to stall. So video cannot run on a 10% lossy link. So what we'll do here now is we have our business policies, and so we're going to say for active-active multipathing, we actually want to use the redundant path to be able to send forward error correction codes, right? So full bandwidth on one link, but error correction on the other link. And so now the way that we can apply that from this screen with one click, I can apply that across my entire fabric of SD-WAN nodes, right? So one click here, which is save. And it can take up to 10 seconds or so to propagate to the devices. But basically what you'll see at that point is the bandwidth will recover. So you can already see it on the graph here on the left one, the MPLS. You can see that it's now going back to full bandwidth. And the video is back to its normal state. So this sort of ability to detect brownouts is something that's very unique to a overlay architecture. And so that's the way that SolarPeak's implemented it.